Hello friends, Mr. Burrell here. We're just at the beginning of our unit on trigonometry. So in our last video, in our last lesson, we talked about the Pythagorean theorem, which is something that you'd already been exposed to before. We talked about how if I know two of the sides of a right triangle, I can find the third side using the Pythagorean theorem. And we also discussed being able to label the sides of a right triangle if I have some angle that I'm looking at. Labeling the sides of a right triangle as opposite, adjacent, and hypotenuse. The reason we did that is to prepare us for what we're going to be doing with trigonometry. So this lesson, this video right here, is an introduction to trigonometric ratios. So now we're going to get really talking into what trigonometry is and how we can use it. So by the end of this video, by the end of this lesson, these are the things that I hope that you are able to know and do. I want you to know that the sine is equal to the opposite side divided by the hypotenuse side. That the cosine is equal to the adjacent side divided by the hypotenuse side. And that the tangent is equal to the opposite side divided by the adjacent side. And find sine, cosine, and tangent values and their inverses of a given angle using a calculator. So all of that terminology should be pretty new. You probably haven't heard it before. That's okay. That's why we're talking about it now. So, as we're getting into trigonometry, this is something, again, that you guys haven't really been exposed to. You've talked a lot about algebra in your past math classes, a lot about geometry in your past math classes. So trigonometry is the branch of mathematics dealing with the relations of the sides and angles of triangles. That's basically what trigonometry is. Dealing with the relations of the sides and angles of triangles. So we're going to be doing a lot with triangles, their angles and sides, specifically in this unit with right triangles. There's lots of really cool things that kind of pop up and happen with right triangles. So a little history for my history buffs out there. Astronomy might be considered the driving force behind trigonometry. These ancient Greek mathematician guys such as Hipparchus, Menelaus, I think is how you say his name, Ptolemy, as early as like 160 BC, so over 2,000 years ago, they used trigonometry to, among other things, determine the rising and setting times of certain stars in the sky. So they used what we're going to be talking about here, trigonometry, to determine how long these stars in our solar system, in our galaxy, stayed in the sky, and calculated like the times that it would take for them to return back into our visual, in the sky. Pretty cool start to trigonometry. So that's kind of where all of this started. So remember, yesterday, or in the last lesson we talked about, if I have a right triangle and I'm looking at some specific angle, say I put my thumb on that angle, all right? I said if I put my thumb on that angle, the side opposite the right angle is always the hypotenuse. The side that my thumb is touching is the adjacent side. The side that my thumb is not touching is the opposite side. Get that in your brain. That's going to be so helpful throughout the rest of this unit. This is the hypotenuse side. The side I'm touching on this angle is the adjacent side. The side I'm not touching is the opposite side. So, in trigonometry, the main functions that we are going to use are sine, cosine, and tangent. Those are abbreviated sin, cos, and tan. S-I-N-C-O-S and T-A-N. Most often you'll see them written that way. In your calculator, they're written that way. You'll probably notice on your calculator, like right there in the middle, we have the sine, cosine, and tangent buttons, abbreviated sin, cos, and tan. They're probably inverted on your screen. But those are the main functions we're going to use. So before we do anything, to deal with the trigonometry we're going to be doing, our calculator needs to be in the right mode. So in your calculator, whether you're using a calculator like mine, or if you're in Desmos, or if you're in one of your home calculators, this might be a little bit different. But in my calculator, if I push the mode button, which is up here next to this blue button, if I push mode, and I go down to the fourth option, there's a radian and a degree option. Make sure that whatever calculator you're using, with everything we do in this unit, that the degree option is selected. And then you press enter when the cursor is over degree, and you should be in good shape. Because the angles that we're going to be dealing with are in degrees. If you're curious what this means, just wait until Math 3. We talk about what radians are. Okay, so I want to show you a little something here. So I'm going to use this to kind of illustrate what we're going to be starting to talk about with trigonometry. So I have a right triangle here. I know that's a right triangle because this right here is a 90-degree angle. I have this angle that's 20 degrees and this angle that's 70 degrees. Okay? So keep that in mind. So what I want us to do, I'm going to really quickly label the sides of this triangle according to the labeling that we did before. So say I'm looking at this angle right here, angle A. That means the hypotenuse side is this one, 8.13. This is the opposite side, and this is the adjacent side, right? So say I take the opposite side divided by the hypotenuse side. What if I take 2.78 divided by 8.13? Take a second, do that in your calculator. Tell me what you get. 2.78 divided by 8.13. That gave me 0.342. When I divided the opposite and the hypotenuse sides, I got 0.342. Okay? So, let me pull this up real quick. Notice, oh, yeah, get that out of the way. Notice right here, it kind of did the math for me. The opposite divided by the hypotenuse side was 0.34-ish. It also did the adjacent divided by the hypotenuse side, and the opposite divided by the adjacent side. It gave me all of those fractions, okay? And wrote them as decimals. So I'm going to go ahead and I'm going to make my triangle really big here. So now, this is still over here is the opposite side. This is the adjacent side. This is the hypotenuse side. So I want you again, I haven't changed the angles in my triangle. I've only changed the sides. So I want us to go ahead and take the opposite side, 6.55, divided by the hypotenuse side again, which is 19.16. Do that in your calculator. Check out what happens. 6.55 divided by 19.16. Huh. I get 0.342 again. Coincidence? Is that a coincidence? Let me erase all this real quick. So let me click on this next button again. So notice, again, the opposite divided by the hypotenuse sides is still 0.34. The adjacent divided by hypotenuse side is still 0.94. The opposite divided by adjacent side is still 0.36. And notice, as long as I keep the angles the same, if I move this triangle around, those ratios, those decimals from dividing those sides, stays the same. Even if it's this really tiny triangle, 0.34, 0.94, 0.36. If it's this really big triangle, 0.34, 0.94, 0.36. That's pretty cool. That's pretty crazy. Well, I know what you might be thinking. Mr. Burrell, that's just because you have a 20-degree angle. What if that angle was bigger? Okay, let's say, I don't know, let's say like a 50-degree angle. So in this 50-degree angle, notice the opposite divided by the hypotenuse side, 3.82 divided by 4.98 is 0.77. This one's 0.64. This one's 1.19. If I make it a little bit bigger, big as I want, even off the screen, it's still, the opposite divided by hypotenuse side is 0.77. The adjacent divided by hypotenuse side is 0.64. The opposite divided by adjacent side is still 1.19. No matter what angle that I choose, say this 40-degree angle, the ratios or the fractions of these different sides, opposite divided by hypotenuse, adjacent divided by hypotenuse, and opposite divided by adjacent, the ratios of those sides will always be the same for a given angle, no matter how big the triangle is. That's, I mean, that's pretty cool. That is pretty cool. So, we're going to give a name to each of those ratios, to each of those fractions. So, that opposite divided by hypotenuse relationship, this one right here, we're going to call that the sine. So we're going to say the sine of an angle is the ratio or the fraction of the side opposite that angle divided by the length of the hypotenuse. So the opposite side divided by the hypotenuse. That's what we're going to call that fraction, is the sine. Okay? So for example, if I'm looking at angle X, this one right here, this is the opposite, adjacent, and hypotenuse sides. So the sine of angle X would be equal to the opposite side, which is 5, divided by the hypotenuse side. Opposite divided by hypotenuse, which is 5 divided by 13. So the sine of that angle, whatever that angle is, I don't know what it is right here, but the sine of that angle is going to be 5 divided by 13, the opposite divided by the hypotenuse side. Okay? We're going to define the ratio of the adjacent side divided by the hypotenuse side as the cosine. So the cosine of an angle is the ratio of the side adjacent to that angle divided by the length of the hypotenuse. So the cosine of an angle is the adjacent side divided by the hypotenuse side. So if I look at this same triangle, the cosine of angle x would be the adjacent side divided by the hypotenuse. Well, if this is angle x, this is opposite, adjacent, hypotenuse. So the cosine of that angle would be equal to 12 divided by 13. The adjacent side divided by the hypotenuse side. Okay? And the last fraction, the last ratio we're going to talk about is the opposite side divided by the adjacent side. We're going to call that the tangent. So the tangent of an angle is the ratio of the side opposite that angle divided by the length of the adjacent side. So the tangent of an angle is the opposite side divided by the adjacent side. That's what the name we're going to give to that relationship, that fraction. So in this same triangle here, if I'm looking at this angle, this is my opposite side, adjacent side, hypotenuse side, because this is the right angle. I should have pointed that out on the other triangles. So the tangent of angle x here is going to be the opposite side divided by the adjacent side, or 5 divided by 12. Okay? I don't even need to know what that angle is, but I know that the tangent relationship of that angle is the opposite divided by adjacent sides, or 5 over 12. Okay? So all those different fractions might seem like a lot to remember. It might seem like you're going to get them mixed up a lot. So here's kind of like a mnemonic to help you remember the relationship between each of these sides. The mnemonic is SOHCAHTOA. SOHCAHTOA. So this SOH part standing for sine is opposite over hypotenuse. Ka is standing for cosine is adjacent over hypotenuse. And TOA is short for tangent is opposite over adjacent. So SOHCAHTOA. SOHCAHTOA. I'll have that like written on the board. You can tattoo that across your forehead, write it on your mirror. SOHCAHTOA is a really convenient way to remember the order and the fractions associated with each of these different trigonometric functions. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent, which stands for SOHCAHTOA. 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 Can I say that enough times it'll drive you crazy? So, for example, this is an example of what your homework might look like. So one might say sine of angle C. So here's angle C right here. If that's the angle, if I put my thumb on that angle right there, there's my thumb. The side opposite the right angle is the hypotenuse side. The side that I'm touching is the adjacent. The side that I'm not touching is the opposite. So the sine of angle C is going to be equal to, if I think back to SOHCAHTOA, sine is opposite over hypotenuse. Opposite divided by hypotenuse, which would be 24 over 30. So for that part of my homework, that's my answer. That's all I'm doing. So like if I look at this triangle, angle C, this is the hypotenuse side, the adjacent side, and the opposite side. Cosine of angle C, if I look at SOHCAHTOA, is adjacent over hypotenuse, which in this triangle is 16 over 20. And that's my final answer, 16 over 20. If I'm looking at the tangent of angle C, here's angle C. Again, this is the hypotenuse, the opposite, and the adjacent sides. Tangent of angle C, if I look at SOHCAHTOA, is opposite divided by adjacent, which in this triangle is 16 divided by 30. And that would be my final answer. Each of these you could simplify the fractions a little bit more, but I'm not going to be super picky on that. But those are the ratios, the fractions associated with each of those trigonometric or those trig functions. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. Now I'll let you do those ones on your own. You can pause this and do those ones on your own. So in your guided notes, if you have the guided notes, you have a section like this. So say I have angle A here. Let me look at all these angle A ones first. For angle A, this would be opposite, adjacent, and hypotenuse. So sine of angle A would be opposite over hypotenuse, which would be 8 over 17. Cosine of angle A would be adjacent over hypotenuse, which would be 15 over 17. And then tangent of angle A would be opposite over adjacent, which is 8 over 15. Now let me look at angle B. So if I'm looking at angle B, let me erase these. If I'm looking at angle B, I have to relabel my sides because I'm looking at a different angle. This is still the hypotenuse, but this is the opposite side. This is the adjacent side. So sine of angle B is opposite over hypotenuse, which is now 15 over 17. Cosine of angle B is adjacent over hypotenuse, which is 8 over 17. Check this out. Check this out. Anyways, we'll come back to that. Tangent of angle B is opposite over adjacent, which is 15 over 8. So that's what a good chunk of your homework is going to be doing, is identifying these different trigonometric ratios. Opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. Okay, so since these trig ratios are used so often, we have calculator commands to compute them, no matter what the side lengths are. So let me pull this up here, again here. So if I refresh this, the first angle that we looked at here was 20 degrees. And we determined that the opposite over the hypotenuse was equal to 0.34, etc., etc., etc. Well, opposite divided by hypotenuse, what did we say that was? Opposite divided by hypotenuse, that's the sine. So the sine of angle 20 must be 0.34. Whoops, 0.34. Okay. So sine of angle 20 must be 0.34. Well, let's check something out here. Let me pull up Desmos here. I'm going to go ahead and type in Desmos. Sine of 20 degrees. Oh, I'm going to change this, make sure my calculator is in degrees in the settings. Sine of 20 degrees is 0.34. What was the cosine adjacent over hypotenuse of 20 degrees? 0.94. So cosine of 20 degrees is 0.94, 0.93969, whatever. Tangent of 20 degrees is 0.36, and alas, tangent of 20 degrees was 0.36. So because these trig ratios pop up so often, and there's a million different kinds of triangles, because I could drag this point forever and ever and ever, as long as it has this same angle, those fractions will still stay the same. Because of that relationship, our calculators, whether it's Desmos or these calculators, can find, if I give you an angle, it has this plethora of knowledge in it, it has a billion different kinds of triangles, a billion different shapes of triangles, and it can tell you what the fraction of the sides of a triangle with 20 degrees would be. It can tell you what the fraction of the sides of a 45 degree angle in a triangle would be, etc., etc. So if I give you an angle without even giving you the triangle, you can be able to find the decimal associated with the fraction of those trigonometric ratios. So say I have a triangle right here where this angle is 26 degrees. I don't know what the sides are, but this would be opposite, adjacent, and hypotenuse. The sine of that angle, 26 degrees, or the opposite divided by the hypotenuse side for any right triangle that has a 26 degree angle, if I type that in my calculator, I'm typing it in my calculator, you can see it backwards there. But if I type in sine of 26 degrees, that's, say, 0.438. Okay? If I pull back up Desmos and I type in sine of 26 degrees, it gives me 0.438. If I type in a cosine of 53 degrees, I get 0.602. So any triangle, any right triangle with a 53 degree angle, the adjacent divided by the hypotenuse sides would reduce to about 0.602. Cosine of 34 degrees is 0.829. I'm just plugging these in my calculator at this point. Again, this is what it'll look like in my calculator. It's inverted for you, but I just type in, so like for this next one, sine of 12, which is 0.208. Tangent of 12 is 0.213-ish. Tangent of 21 is 0.384. So if I give you an angle, you can use your calculator to find what those trig ratios would be, what those decimals of those fractions would be. So same, and we're going to talk about this a little bit more later, but also if I told you this triangle right here, with this, the opposite, adjacent, and hypotenuse sides to this angle. Say I told you that this side was 3 units long, this side was 5 units long. So the cosine of this angle right here was, the sine of this angle right here was equal to 3/5. Our calculator also has the ability to undo sine, cosine, or tangent. Okay? So given the following sine, cosine, or tangent values, I can find the inverse of those values. And we'll talk about this later, how really that's giving me what the angle is. So before, if I gave you the angle, my calculator can tell you what the sine, cosine, or tangent fractions are. If I give you what the sine, cosine, or tangent fractions are, you can use the inverse sine, cosine, and tangent to find the angles. So in our calculators, the way that you do the inverse sine, cosine, and tangent is by pushing this second button. So if I push the second button and then sine, it pops up with this little sign of -1. So if I type in that inverse sine of 0.5, I get 30. So basically that's saying the sine of a 30-degree angle would be 0.5. The fraction of the opposite and hypotenuse sides in a 30-degree triangle would be 0.5. If I do the inverse cosine of 0.25, I get 75.52 degrees. So the cosine of a 75.52 degree triangle would be 0.25. Say I do this one, the inverse tangent of 5 divided by 12 gives me 22.62 degrees. So if I had a 22-ish degree triangle, the ratio of the opposite and the opposite and adjacent sides would be 5/12. So lots of really cool tools associated with these sine, cosine, and tangent values. Lots of really cool things we can do in our calculators. Lots of really cool relationships that exist. The big thing on your guided note or in your homework is going to be able to be doing this. If I give you a triangle, you should be able to identify the sine, cosine, and tangent fractions based on the sides that are given. And we're going to talk about more about these typing into the calculator in the upcoming lessons. So hopefully now you know what sine, cosine, and tangent, those ratios, are equal to given a right triangle. And a little bit, we're starting to know how to find the sine, cosine, and tangent values and their inverses of a given angle using a calculator. So that's all I have for you today. I hope that was helpful. Please don't hesitate to reach out to me if you have any questions whatsoever. I hope that you enjoyed that as much as I did.